In the previous lessons, we learned how to calculate Q equal to MCAT, and Q is heat, and the unit for heat is joule. And Q, or heat, is equal to mass times specific heat capacity for that particular substance. So different substance will have different C times the delta T, and delta is always final minus initial. In order to use this equation, we need to know the unit for each of the variable. Well, Q is heat, and heat is measured in joule. And then M is your mass, which is in grams. And C is your specific heat capacity, which is joule over grams times Celsius. So therefore, this T right here must be in Celsius. And in the process, we also learn that when Q is negative, we know that it is loss in energy. And when Q is positive, it is gaining energy. So it's important to understand if Q is going to be positive or negative based on the problem. And one last thing that we are going to apply in this lesson is that when we have a loss in energy, the amount of energy loss is equal to the amount of energy being gained. That's why we have negative Q equal to positive Q. Now let's apply these two concepts to solve some problem. How many joules are needed to warm? Think about warming. To warm something, you take in energy, right? Okay, to warm 27.0 grams. And this right here would be your mass right there, okay, of copper. And this is the substance, copper. And we know that from 30 degrees Celsius to 85 degrees Celsius. So think of the terminology. From, that would be initial. So this would be your initial temperature right here. And then from to where? Well, in this case, to 85. So that's your final. So don't try to memorize smaller number minus larger number, or larger minus number smaller. Think of the basic English terminology. You're starting from, that's your initial, and ending at your final. And the specific heat of copper is 0.385 joule over gram times Celsius. So this is your C right there, okay? Now let's plug into this equation. Well, it's asking for joule, and joule is represented by the variable Q. So in this case, we are solving for Q, and again, Q is equal to MCAT. And of course, let's plug into the equation right here. So right here, we would have your M right there. Now let's continue. So in this case, can we plug in the values? What's the values for M? That's mass. So that is 27.0. And what is your specific heat capacity, which is 0.385? See, if you know the unit and you know what the variable represents, you just plug it in. And then lastly, your delta T, which is going to be your final 85 minus your initial. In this case, is 85.0 minus your 30.0. And all you have to do is just plug in here. 27.0, 0.385, and then final, which is 85.0 minus 30.0. And that's it. Now let's plug this into a calculator using parentheses. And notice how I didn't use the multiplication sign, because when you have a number using parentheses, they are multiplied to each other. And this is our answer in joules. And notice how I have two boxes. The first box is your number, and the second box is the unit. And in this case, if you notice, is the system gain or lost energy? Well, this is a positive values, so this means it has gained energy. If it's negative, it will lose energy to the surrounding.